All right, today we're going to have a look at Lesson 78, Graphing Rational Functions. We've got to get some definitions right out of the blocks. And first of all, we need to talk about what a rational function is. Okay, so what is a rational function? Who thinks they might be able to kind of give me an idea what we mean by rational function? Anybody? That's not a bad guess. It's not correct, but it does have something to do with the definition of a rational number. Karis? No, don't read from the textbook. Josh? Well, it's certainly going to have function notation, right? So if we're using functions, if we're talking about function notation, we're going to be dealing with something that is like f of x. All right, Nick?
Functions where x is always a rational number, or where the variable's always rational.
The variable is always a rational number, so the x, the domain, so what you're trying to say is that the domain is rational numbers. That's not correct. I mean, we could talk about a function that looked like that. It would be kind of a messy animal because the irrational numbers are infinite set, and so are the rational numbers. You're going to need to take notes today. So a rational function, what is a rational number? Number that can be written in fraction form. So rational functions are functions where there is a variable in the denominator of a fraction. It comes from rational expressions. Remember how we defined a rational expression earlier in the class? Something like 2x over x minus 3. That's a rational expression. And what do we do with that rational expression? What kind of problems, what kind of questions did we ask related to 2x over x minus 3? What are the excluded values for x? So what can x not be equal to in this? X cannot equal 3. That's going to play into this lesson. All right, so this lesson is going to have expressions that look like that. All right, so the standard form of a rational function is f of x equals a over x minus h plus k. Now, what a, h, and k are just numbers of some kind. Okay? Anything that has a variable in the denominator like this is a rational function. Okay? Yes?
So what is the actual definition?
That's it. It's a function that has a variable in the denominator. That's, if you wanted a word definition, it's a function that has a variable in the denominator. All right? So in this deal, we're going to kind of look at some things. So let's talk right out of the blocks. What is the excluded value of x? In this expression, what can x not equal? X cannot be h. That's correct. X cannot be equal to h. Okay? And furthermore, hey Jack, you got to tune in, buddy. Lean up, pencil in hand, and let's go. Just going to punt this one, I guess. X equals h, because that breaks the function badly, right? If we put x equals h into there, if we put h in for x, we have a broken machine. We got a 0 in the denominator. That's terrible. It's a disaster. Okay, x equals h, and this is a new definition, is called a vertical asymptote. I know it's a strange word. A vertical asymptote. Okay? Now, this thing, we're going to talk about what the graph would look like in just a moment, but we're going to do that in the context of a more concrete examples. Now, you're going to need to know this formula If you don't know this formula and you don't know this, x equals h is the vertical asymptote, you're going to miss 2 or 3 easy questions on the next test. Okay, now let's look at a practical example of this. I'm going to turn in the textbook and work some of the examples that they give us in the textbook. Y equals 2 over x minus 8. Now, keep in mind that this is y equals, but we could have also easily done f of x equals. We could actually use function notation because y is a function of x. What value breaks this function? X equals 8 breaks this function, right? So my excluded value is x cannot be 8. And that means that x equals 8 is a vertical asymptote. Okay? Y'all have your graphing calculators handy? All right, I want you to grab those. And I want you to kind of examine what you see when you graph y equals 2 divided by x minus 8. Now, the way you're going to have to put this in your graphing calculator is y1 equals 2 divided by parentheses x minus 8 close parentheses. We have to tell the calculator that the 2 is being divided by the entire expression x minus 8. Now, some of your calculators will go into fraction form, which is fine, and you can just plug it in and make it look exactly like this. Okay? All right, so your calculators are kind of off because you've done some other things. You could start over if you wanted to do second plus 712, but you could also just do zoom and the number 6. That's going to give you a standard viewing window from -10 to 10 and for the x and your y-axis. Okay? Nice. Then what you're going to get is something that looks a little bit odd, right? It looks like something that we've graphed before. What does it look like that we've graphed before? Do any of you remember? Inverse variation. That's exactly right. Because this is very much like, y'all listen, y equals 2 over x minus 8 is very, very similar to y equals 2 over x. You know, and we graphed that. If you wanted to see a little bit more of your graph in your calculator, you could go into your window. Go into your window and change the x max to make it 16. Leave everything else the same, and then you'll kind of see what's going on. Now, do you see a kind of a barrier there? You see what's happening at x equals 8? You can't see the line, but there is a break in the function there, right? Your graph looks something like this. Let me give myself a little more room. Your graph looks something like this. At x equals 8, there's an invisible line. You can't see it, but that's our vertical asymptote. And then on this side of the graph, we've got this nice little shape. And then on this side, we've got this nice little shape doing something like that. So your graph should look something like that. And that looks exactly like our inverse variation graph, except it's slid over to the right 8 units. This is our vertical asymptote. X cannot be 8. Now, what your graph is on continuous is something. It's just kind of like a little. It's not really there. You could change a mode there, and it wouldn't show that little jump or that squiggly thing there. All right? Does everybody see what's going on here? Now, there's 2 things happening. Y'all listen very carefully. Are y'all listening? Because in this expression that we started with up here, x cannot be 8, right? If x cannot be 8 in this expression, what can y never equal to? Of course it can't be. What value can this expression never take on? It can never be equal to 0. 2 over 0 is meaningless. Of course it can't be 2 over 0. That doesn't mean anything. This value, this y value, can never be 0. All right, so our horizontal asymptote is 0. And if you graph y equals 0 is actually the x-axis. It's the horizontal line right here. This is my horizontal asymptote, and this is a vertical asymptote for that graph. So y'all can see that your graph is going to get closer and closer to 0, closer and closer to the x-axis, but it's never going to get there. Y can never be equal to 0. Okay? Now we're going to kind of dress things up a little bit. Let's do another example. Move on. And we didn't define this thing yet, but in this particular problem, y equals 0 is the horizontal asymptote. So every rational function is going to have a vertical asymptote and a horizontal asymptote. We're going to learn how to identify both of those. Let's look at one. Y equals 4 over x plus 1 plus 2. Y equals 4 over x plus 1 plus 2. Now, before you go to your calculators, let's talk about what we know algebraically. What's the vertical asymptote going to be? X equals negative 1. Okay, so my vertical asymptote is going to be x equals negative 1. Because that breaks. That's the excluded value of x. X can't be that. If you plug that into the machine is broken. You can't divide by 0. There's no value there. It's a hole. It's a broken place in the function. Now, what do you think the horizontal asymptote is going to be for this one before we graph it? What's the horizontal asymptote going to be? If this can never be 0, right, then y can never be 2. Okay, so y equals 2 is the horizontal asymptote for this graph. Okay, now without a graphing calculator, you guys are welcome to do this on your graphing calculator, but I'm going to show you what this is going to look like. We're going to have a vertical asymptote at negative 1. We're going to have a horizontal asymptote at y equals 2.
Why is the horizontal asymptote?
I'm going to show you in just a second. Let's just kind of go through it, and we'll look at this. We'll look at that closer in just a moment. And this thing is going to look something like this. The graph's always going to look the same. It hugs the asymptotes just like this. So plug that into your calculator and see if you don't see exactly what I'm talking about. 4 divided by, remember you've got to have the x plus 1 in parentheses plus 2. Then your graph should look like that, right? Okay, so we're plugging things in for x. Hadley, back to your question. As we plug things in for x, you can keep putting things into this, different numbers, positive numbers, negative numbers, big numbers, small numbers, fractions. We can put anything in there except for x equals negative 1. Okay, so no matter what I put in here, 4 divided by a number can never be equal to 0, right? And so because this expression can never be equal to 0, then y can never be equal to 0 plus 2. Y can never be equal to 2. Because your rational expression can't be equal to 0. This particular rational expression can't be equal to 0. And so y equals 2 is the horizontal asymptote. The function is going to get very, very close to 2 because this expression can be very, very close to 0, but it can never be 0. So y equals 2 is my horizontal asymptote. All right, now let's leave the calculators and let's go to an expression like this. Next example, y equals 1 over x minus 4 minus 2. What's the vertical asymptote going to be?
4.
Vertical asymptote is x equals 4. Right? Because that's the value that really messes things up. What's the horizontal asymptote going to be?
-2.
Y equals -2 is the horizontal asymptote. So we can do a sketch of the graph, right? X equals 4, vertical asymptote. That's right there at 4. Y equals -2. Is the horizontal asymptote, and then the rational function is always going to take the same shape.
Why wouldn't the horizontal asymptote be 2? Because 2 minus 2 is 0. Wait, no, I shouldn't have said that.
All right. Okay, y'all okay with this? Now let's go back to the formula. Let's go back to the formula. F of x, or y, equals a over x minus h plus k. The vertical asymptote is always x equals h. The horizontal asymptote is always y equals k. So these are the facts that could help you kind of identify the vertical asymptote, identify the horizontal asymptote. The shape's always going to be the same as that shape of our parent function, which is just our good old inverse variation that we looked at before. Okay? Any questions?